Welcome to this short recorded video where I will go over solutions to the external activities for the Part B Module 3 notebook. So the first activity involves an advanced weight converter function. So we are using NumPy, so I'm going to make sure that we've imported NumPy as NP. And the first part of this, I create a couple of arrays. I create an array of kilograms and pounds, weights in these units, and then I create a dictionary that I call weights without the vowels in the name for the variable. So one of the things that I show, is really the first thing I show after creating that cell, is that you can iterate, meaning use a for loop, the keywords in a dictionary. And I'm showing this below. And so it's just for I in weights, then that's going to be the keywords, which is going to be the kilogram and the pounds. And so they're going to be string type variables. And then I just show what type of variable arrays show up as, because we've actually not looked at the type of an array. We do np.array to create an array, but if we look at the outputs of this, we see that I, when we do for I in weights, is a string object that's either kilogram or pounds. The order of it is just based on the order of the keywords, how when we created the weights. They're not indexed by zeros or ones. It's just the actual string object, the name of the keyword. And the type of object that is an array, which is then this is the kilogram array, and this is the pounds array, or excuse me, the kilogram array the first time I loop through it, and then it's the pounds array the second time I loop through it. We look at the type of that and we say, oh look, it's an ND array, numpy.nd array. So all of that, just showing this, was meant to be useful for when I ask you to write a function called a weight func underscore adv. It's just an advanced weight function compared to what we've done previously, and it has a single parameter weights. So if you just read that initially, then you would know that this is what you'd have to do. You'd have to define a weight function with the underscore adv name, and it has a single parameter. And so that should just be the first thing you do as soon as you read that part of the instructions. It is assumed to be of type dict for a dictionary, and it contains the keywords kilogram and pounds that point to the arrays kilogram and pounds respectively, that are what we've seen above. So the function should loop through the keywords in weights. All right. So what do I mean by that? I mean, it should be just like what I showed here to loop through the keywords for I in weights. For I in weights. There we go. I'm now looping through the keywords. And if the keyword is kilogram, kg in the string, then every value in that array should be converted to pounds. Else, every value in pounds which would be in the pounds array, should be converted to kilograms. These conversions should be printed to screen. So quite simply, I check if I is equal to the variable kg. And if it is, I want to print to screen that given, let's say, kilograms, and you could do like a return line and say, okay, here's the weights, right, in kilograms. And then I can do a new line again and say, this is in kilograms and it's converted to, let's say, pounds. That I also do is and put it in a new line. And then I take weights I times, let's say, 2.2. All right, roughly speaking, whatever the exact numbers you use is fine, but the conversion is about, every kilogram is about 2.2 pounds. You could have used a more accurate constant if you wanted. I don't really care. The point is really seeing the structure. Now, this, even though it's weights of I, and that would be weights of kilograms, so that's going to be the whole array of weights. This is an array operation. I'm multiplying every element in the array by the constant 2.2. You could also loop over all the entries in here if you'd like in this array. I don't ask you to do that though. So I'm asking you just to loop through the keywords. So this is sufficient. This is a very clean way to do it. And then the other condition, right? If I is not kilograms, then it must be pounds. And so then I just want to do something similar like, hey, let's create a new line because it's going to be printed after this one. And it would be given pounds. I'm just going to kind of show it here, weights I. So this is just going to print the pounds weights. And then I'm going to create a new line and say that's pounds converted to kilograms. So I'm just kind of structuring this very similarly to the code that's right above it. And I would take that whole array of pounds and divide it by 2.2 or whatever, specific constant you used. So if you have just this function, I'll just show you what happens when I run this function. This is what the output looks like. It's given kilograms here, and then kilograms converted to pounds is given here, right? So that's taking the kilogram array that is 100, 200, 300, and then it's taking and converting it, multiplying each value by 2.2, or again, whatever constant you put there. And then it's going through the next keyword in weights, and it's then printing out the pounds to kilograms. And so that's just what's going on down here. And then, I create a new array, and I show, because these arrays don't have to be the same, or I create a kilogram and pounds arrays and the dictionary new weights all together. The arrays have different sizes, and this should also run without error. So the arrays don't have to be the same size, because I'm just converting whatever the array is all at once by this operation. Now, that just has the functionality of what the output should be. What I haven't done yet is do any of the additional instructions, like add a docstring or use the is_instance command to make sure that this parameter that is passed, the single parameter that's passed into this function, is of type dict, and that the kilogram and pounds variables that are pointed to by the keywords within it are of type numpy.ndArray. So there's a lot of ways to do that. You could do it all at once. You could add your docstring. So you should have a docstring. I'm not going to write a docstring here, but you should have put a docstring here. And then, I would say you could do like if not is_instance weights dict and is_instance, then you would check, let's say, weights I. You have to check that, our weights, let's say kilogram. That's what we need to check. There we go. Is in numpy.ndArray. And then similarly, and is_instance weights, let's say pounds, and then np.ndArray. And if that turns out to be true, because I put the not here, then at least one of these things failed. And so then, I would print something like, this, and, an incorrect input parameter was given. The parameter should be of type dict. And maybe I'll put a new line here just because it's getting a little long. And then, print another thing like, and it should have keywords. Let's do this, kilogram. So I have, because the tick is a reserved character, I use a backslash here to actually print ticks. And the kilogram and let's say pounds keywords should be of type np.ndArray. All right, and then final tick mark to end that whole string, and then really you should return at that point. There's no point in going on. So that's it. Let's say run that, and you see everything works. This stuff all works. But let's say I just try to run my weight function with, let's say, just a, let's say I could do it with a kilogram array, right? Because I created this kilogram array up here. So I'm not giving an input of type dict, so this should immediately fail. In fact, this will fail as well. It might print out another error, but it should fail. The point is it should fail. And we definitely see an incorrect parameter input was given. The parameter should be of type dict, and it should have keywords, kilogram, and pounds. And actually, I don't need the new line array because I used a new print command. There we go. I'll fix that up. So, that's the proper functionality. So that's it for that first activity. There's other ways, again, that you could do things in terms of, like I said, you could loop through all these individual components of these arrays. There's just no need to. This is really just the functionality I was after. And again, it comes down to reading the instructions. The function should loop through the keywords and weights. And then if, notice what I'm saying, if it's equal to kilograms, then it should convert that array to pounds. Else, right? And so there's the else. It should convert the pounds array to kilograms. So that's all we did. If you just look, all I'm writing in the instructions are really like each part of the instructions is corresponding to a specific line of code. I'm using the language more conversationally here, but precisely. Now, as far as this activity goes, I'm just going to show the function, the DCF function, because we have this summation. So I'll just leave that up on the screen for people to see it for a second. So the point of this is that you sum up from 1 to n 1 plus r to the I power in the denominator, and then you're just indexing the cash flow in years 1, 2, 3, and so on. Now, because our Python indexing of an array or a list starts at 0, and we're going to have these CF values be in a list, or excuse me, be in an array, then if we run our loop from 1 to n, then we're going to have to shift the index. If the I is varying from 1 to n, this is going to have to vary from I minus 1 to the calling of the list component will have to be I minus 1, or array component, excuse me, in order to access the correct component of that. I think it's just easier to see this, but again, this function, make a function DCF advance. So let's just do it. Define DCF advance, and it should have CF, R, and N as parameters that computes this using a for loop and formula above. So like that should be the first thing you start to write. And then one of the things I also say is, hey, the N and the R value should be defaulted. So let's look at what those are. So R should be 0.05 as a default, and the N should be a default of 5. And then we're going to check the types. I'm just going to skip over that to get to what the point of this is. So I want to do the looping. This is basically what you need to do after you do the type. So I'll just say like you should have, some doc string goes here. You should actually write a useful doc string, and then some type checking with is instance goes here. Again, you should have that. But the main part is this. You have DCF, and this is just a summation. Well, we saw a summation of partial sums in our lecture notebook. So I'm just doing this again. It's just like a partial sum. I'm summing up to n. So it would be very similar. I'd say DCF equals 0 just to initiate the sum. I could have for I in range. I'm going to do this in two ways. First, I'm just going to say from range 0 to n. All right. So I'm going to use Python indexing in this range. I want to just loop from I to n. Now, what I want to systematically add is each component in the sum through each loop. So I'm going to take the CF array, and I'm taking that first component, and then I'm dividing it by 1 plus r raised to the I plus, man, I keep hitting the delete key, excuse me, I plus 1. So when it's I plus 1, that makes sure that when I is 0, I'm just like basically shifting the sum to 0. That needs to be to the first power still. That's supposed to be to 1. But so if I is 0 and that's supposed to be 1, I need to do I plus 1. Just like that. I do this, and then I say, you're supposed to print the final value to the screen and also return the value to the user. So it should have like, print the final DCF is, and or however you want to say it, and then you could print your DCF to screen, and then also return the DCF. That's what I'm asking you to do. But this is how complicated the functionality of the code is. It's just these few lines. I'm not looking for anything overly complicated here. And that works if you do this range from 0 to n. So that accesses all the n entries that are in the CF array, and it divides them by 1 plus r raised to the correct power. And again, it's the I plus 1 because here I'm starting I at 0. So I just have to shift it so I raise it to the correct power. Now, if you made this 1 instead, like you said, oh, I'm going to start summation from 1. Remember the way the way that range works is it goes 1 up to, but not including n here. So you'd have to go to 1 to n plus 1 to sum up from 1 to n. And now the I values are correct as far as the powers are concerned, but the indexing is off for the array because array indexing starts at 0. So when I is 1, I need to get the first component of the CF array. I just put I minus 1 there, right? And so when I is 2, I want the second component. Well, the second component is CF of 1, right? Because CF of 0 is the first component, CF of 1 is the second, and so on. So that's the only shift. Either one of these was correct. I'd accept either one. And you just then have to do some printouts and things that I asked you to do. I'm not going to do that. The whole point is really, this is all I'm looking for as far as the functionality. And then I'm also just checking that you did some docstring, you did the type checking as I was asking, and then you run the results. And also, of course, always, always, always print and interpret results. Like use a markdown cell, explain what's going on, explain something about the code, explain something about the output. Make sure you're interpreting what's going on correctly. So that's all I have to say for this video. Thanks for listening.